Welcome to the final session of the day. This is a focus session about the TeraFlow project, utilizing optical network slicing to connect clouds for autonomic 5G and beyond services. My name is Adrian Farrel, and I'm introducing and moderating this panel session. There will be 4 flash presentations on our tight agenda. Firstly, an overview of the TeraFlow project and its stakeholders from Daniel King. Then, Ricard Vilalta from CTTC will talk about how SDOs are enabling optical network and IT convergence. After that, Oscar Gonzalez de Dios from Telefonica will talk about deploying and integrating automated optical network slicing. And lastly, Håkon Lønsethagen from Telenor will provide some examples of 5G applications and services. After that, we have a short panel question and discussion session that has been pre-recorded. And finally, just to note that because this is a pre-recorded session, there's no opportunity for you to ask questions directly to the panelists, but they are online in the chat tool, so you can type your questions there and they will try to answer them as they go along.
Hello, my name is Daniel King. I'm a consultant at Old Dog Consulting. I'm going to talk to you today about TeraFlow, a European Commission funded project. TeraFlow utilizes optical network slicing to connect clouds for autonomic 5G and beyond 5G services. This presentation provides an overview of the project and underlines its stakeholders. TeraFlow is a European Commission funded project creating an open transport solution for a variety of next generation use cases. These include beyond 5G, automotive and cybersecurity. Each of these verticals is underpinned with the need to handle terabit flows of data. The TeraFlow operating system, a key output from the project, is an open-sourced hierarchical control and orchestration platform using distributed smart connectivity with integrated edge computing and storage resources. The TeraFlow operating system will work with open source communities and the Open Network Foundation and Open Network Operating System, amongst others. It's important for the project to have industrial impact as well. We're also actively contributing and leading a variety of standards around control and operation of technical and resources. The optical slicing is a key component of TeraFlow, and we'll cover that further in subsequent presentations. TeraFlow will create a new type of secure cloud-native SDN controller and NFV orchestrator that will radically advance the state-of-the-art in beyond 5G networks. This new SDN controller shall be able to integrate with the current NFV and multi-edge computing framework, as well as providing revolutionary features for flow management and optical and microwave device network management. The target pool of stakeholders expands beyond the traditional telecom and service provider towards edge and hyperscale cloud providers. They will benefit from TeraFlow by exploiting a new type of controller and orchestrator whilst achieving substantially reduced costs with increased agility for novel, highly dynamic network services and zero-touch automation and provisioning features. The TeraFlow architecture will be validated through the implementation of the TeraFlow operating system, which uses cloud-native architecture, transport such as optical and microwave network integration, and unification of network and cloud resources, using machine learning-based security and a distributed ledger smart technology. The TeraFlow architecture is designed to accelerate innovation for transport networks, including optical and microwave layers, and also the IP networks that run on top of these underlays in order to provide service connectivity. Ultimately, it will help operators and providers to service their communities and provide connectivity for a variety of emerging applications. The infrastructure will support beyond 5G integration for terabit packets and services across layer 2 and layer 3 VPNs up to the network edge. A key component of the TeraFlow operating system will be the slice manager for automated service management of transport network devices. The SDN controller within the TeraFlow operating system will also integrate with existing telco cloud and mobile edge computing components, enabling multi-tenancy and inter-domain connectivity through the transport network slice controller. To secure this network infrastructure, the TeraFlow operating system includes a cyber threat analysis and protection mechanism. This provides a machine learning based intrusion detection system protecting TeraFlow's services, networks and infrastructure.
Hello, my name is Ricard Vilalta. I'm TeraFlow Project Coordinator and Senior Researcher at CTTC. I want to talk about SDOs which help us enable optical network and IT conversions. So let's first talk about the requirements for optical network automation and the cloud interaction. So we have seen SDN in the market for more than 10 years with great success in the data center world, but operators still have not adopted basic deployments. We are starting to see them now. We see that the telco cloud is evolving slowly. There is no clear path of SDN introduction there. We see that automation is a tool that's needed for network operators to fully benefit from the dynamicity and programmability that SDN brings to the systems. With beyond 5G and 6G networks, massive SDN flows will be needed. Flow aggregation and network core is not inefficient and it does not provide the specific services. We need to break the beam and the WIM paradigm, so computing and network resources shall be addressed in a unified way. So we need these conversions, and also we need to introduce security to our networks. So let's see how the scope of SDOs looks like in this slide. You can observe that we have a transport SDN controller in the middle, which is able to provide transport service abstractions end-to-end onto a top layer, service SDN layer on the operations and business support services, also to OSM, for example, to the NFV orchestrator through the unique warrant management, for example. These can be offered using APIs which are quite well established, like the ONF Transport API or some of the IETF APIs, the data models that I will talk later. This, of course, as they are defined in YANG models, will be provided to upper layers through a RESTconf interface. And that's the same that we see between this transport overall end-to-end controller and the different domain controllers. So you can see there that we have a microwave domain SDN controller, IP domain SDN controller, or even an optical domain SDN controller. This can be exploited through different APIs, typically also using RESTconf, and then for each domain controller towards the different domain network elements, we can exploit different APIs, such as the ones that OpenConfig people is doing, for example, in the routers or in the transport wall, or the APIs that ONF is working on, or also IETF. So we have typically this is done using NetConf. We have a very variety of protocols and data models that support this overall SDN architecture of our network. And let's see how this can be addressed also in IETF. This is the IETF model for network slicing techniques, which helps us integrate the optical network towards the different data centers and also computing services. You can see that we in TeraFlow we are using a combination of generic service models and device models, which are useful for this network slicing deployment. So we can observe the network slice controller, which can be a component, which can be part of the TeraFlow framework. This component it provides an outdoor interface that needs to express the customer details, the endpoints, the connectivity matrices, the different SLOs and SLEs. This can also be understood inside the framework of ACTN, that's abstraction and control of traffic engineering networks. This provides a management architecture and young models for building virtual network services for slicing. We have also been working in the network slices framework documents, which are draft working group drafts, and also we have some early work on a network northbound interface for the slice young data model. We are also collaborating in describing the layer 2 VPN network and network models, as you can see in here. That also we are aligning the work that has been done in ACTN towards slicing. That's the ITF draft for ACTN slicing. And finally, we are also contributing in segmenting routing policies, which are one of the ways of delivering ITF network slices. So that's all the work that we are currently doing. So keep in touch with the project to know more. Thank you very much for your attention.
Hi, everybody. Welcome to this session of deploying and integrating the automated optical network slicing in the context of the TeraFlow Workshop. So first of all, we are going to start talking about why we need the optical automation and programming in the operators. So the first of all is to simplify our network operations, okay, to make the life easier to the people that operate the network day to day, and facilitate the integration with the different OSS and BSS systems. Okay, so we're able to create these APIs and have a network management based on APIs. We are going to simplify a lot our network. Also, we can provide new services and increase the revenue by providing these new services that we create. Also, we can make our network better, behave better, so reduce our churn and protect our revenue. Also, we can optimize and maximize our network access. And of course, we can have and deliver services quicker. Okay, so we can have a faster time to market in releasing any new type of service. In this case, it's optical connectivity. It's any kind of programmability formula, so we can deliver these things much faster. So how do we proceed to do this automation? So in order to do the implementation, we need to think what we can do better and faster with less human resources. But take into account that we not only need to automate the common task in the operation, okay, but also program the network. Okay, this is like software. Okay, so we want to build new services that we didn't think at the very beginning. So can we minimize the risk in what we are doing? Of course, yes. The whole idea is not only automation but programmability. Okay, have open programmable interfaces that provide flexibility. If we need to change direction and we need to do something that we didn't think at the very beginning, we can do it. Okay, if we have these APIs that we have in the network, they are like libraries. We can build services on top of them. And which are the kind of services that we have? For example, the network discovery, service fulfillment, manage the lifecycle of our network, do the traffic engineering, facilitate the assurance. So how are we gonna build the optical underlay? So in TeraFlow, we are following the architecture that has been widely adopted by the industry. Here I show you a couple of examples in the industry. For example, the TIP transport SDN architecture or the ICTN architecture in IETF, which are a hierarchical architecture with controllers per domain. For example, there will be one controller for the IP/MPLS network, controllers for the optical domains. And what are the interfaces that we can use? For example, one of the most mature interfaces is the ONF Transport API that can be served as the MBI of the optical networks and provide topology service, connectivity service, a path computation service, virtual network, also has a notification framework, and is able to integrate mainly the optical transport, OTN and WDM. I also point you here, as I said, several works that are ongoing also in IETF to facilitate the optical integration. For example, the access in the cloud, the optical network problem statement, the framework for OTN network slicing also in IETF, and how to apply ACTN to packet over optical networks. Okay, also it's a work that we are doing in IETF. However, we still have a lot of challenges. Okay, so here we are working hardly in Telefonica, and especially here in the context of TeraFlow with other operators and research centers. And we first need to complete the deployment of the SDN domain controllers. I mean, they are ongoing effort, but we need to nail them down and deployment and make them better. Also, the network slicing, there is a whole debate in the industry right now. It's one of the hottest topics right now. And the APIs that you need to use, what are the young model, what are the definitions of what you can program or not, they are still in definition. So there's still a lot of work there. And the hierarchical controller, that is this piece that will include also this slice controller and feeds all the layers together and has all the view of the network, is the next step. I think that will come later. So with this, I conclude my presentation, and thank you for listening.
Hello. In my part, I will go through some examples of 5G applications and services. My name is Håkon Lønsethagen. I'm a senior research scientist at Telenor Research. I will do this by covering two verticals or use case areas. The first one is the automotive sector. Automotive will create unprecedented demands for transport network slices and connectivity. I will start by focusing on one of the TeraFlow motivational claims. With 5G and beyond 5G networks, massive SDN flows will be needed. This illustration is giving some hints in this direction. We see massive amount of automotive vehicles. The vehicles will vary in types and sizes and purposes. We will need to cover not only urban areas, but also suburban and rural areas and highway areas. So the wireless devices will be in the car itself, on the car. And there will be a diversity of applications and services and use cases in this area. By this, we do anticipate a massive increase in volume and variability of endpoints and connections. And these endpoints and connections, they will need to be realized in the different edge cloud data centers, so the local micro data centers, the small, medium data centers, and also regional and national core data centers. We also anticipate and we see various stakeholders, various service providers, digital service providers, providing their own services in this sector. So there will be a need for specialized logical private networks, and they will have to be delivered on demand as on-demand services over multiple public infrastructures. So interconnections in new ways is key here. We also see that the demand will vary highly. So over the time of day, over week, over the year, also the different locations and the demands in different locations driven by the traffic patterns themselves. We also see that there will be different needs for new roaming schemes according to the services and applications that are even difficult today to foresee, not only international or national roaming, but also in-nation roaming. So the automotive sector is a perfect use case area for TeraFlow to study. So the TeraFlow OS and controllers, they need to take a whole lot of needs and requirements into consideration. The second part that I will look into is actually a hybrid use case area, that of Smart Port and Industry Park. The photo is of Herøya Industry Park, where Yara and other industry firms and stakeholders, they do have a variety of 5G and other connectivity needs, including edge cloud and other application needs. So in the Smart Port area, this is actually a trial developed in the 5G Solutions project. Here, Yara, which is a fertilizer company with a global market, they would like to automate their solutions. So eventually, an autonomous ship together with an autonomous crane will be the central element in the port. So the crane will lift containers in and out of the ship, whereas the straddle carriers and multiple of those will go to and from the different production sites to the port. Again, we see a use case area with a lot of highly varying demands and a broad spectrum of demands. Here, I would like to just underline that this is a mix of non-public and public networks and infrastructures. The security and safety demands are somewhat different, which again will put new demands on the TeraFlow slice concepts. Also, the 5G solution technological and business validation methodologies will be applicable to TeraFlow. And then, just some concluding remarks. By 5G and beyond, we do see a radical shift of demands that will certainly be challenging. We need a smarter and more dynamic topologies, allowing a new generation of automation, flexibility, and adaptation. They will map from a diversity of customer needs to operator resources, all based on and driven by quality of experience in real time. We also see a need for new service concept, aligning those from 5G and IETF and other relevant initiatives, providing services on demand over and across interconnected private and public infrastructures and networks. And by this, thank you for your attention.
So thank you to all of our speakers for bringing together a little bit of information about the TeraFlow project. I've got a few questions that I'd like to ask as a panel, and perhaps we could start off with looking at why the use cases that TeraFlow is talking about necessitate automation and why we can't manage networks using conventional tools. So maybe Håkon and Oscar would like to comment on this.
Right, I guess I'll go first. So through the presentation, my part, I tried to show actually the enormous growth of connectivity needs, in particular in the edge and regional part. So this is a huge change to the operators, how to deal with connectivity more local, more regional. And this varies in terms of when the need is there, so the dynamicity will increase enormously. And in terms of the tools, today the tools are more siloed, I would still say, and our capability to see how a more end-to-end approach, along with the slicing ideas that are coming up from the 5G world together with the IETF world, this indeed will require new tools. So that's my short answer.
So Oscar, as an operator, why do you need automation rather than the existing tools?
I would say that existing tools are very good at pure automation. So by pure automation, I mean doing repeated tasks. Okay, so there are things that our operation guys sometimes do day to day, some consulting something. So they do their own scripts, and for that, just repeating things, they do perfectly well. But however, being able to program the network really, okay, so being able to create new services to adapt to the changing landscape that Håkon mentioned.
Let's move on to another question, which is about why network slicing is so important for these use cases. There are many pre-existing techniques like VPNs and private wires and traffic engineering. Can't we use these? And at the optical layer, why can't we use existing techniques like layer 1 VPNs and the much talked about optical connectivity as a service? This one is probably for Oscar and Ricard.
It is true that we have today the VPN technologies. However, we need to go one step further in order to provide the type of connectivity that we need for 5G. So this is why we need to go beyond existing VPNs. And maybe the existing VPNs are one tiny part of what, or one part of what we need done now with extra things. And for the optical networks, it is true that part of the existing services, like you mentioned, the layer 1 VPN or the connectivity as a service, can be used, but they need to be further enhanced to integrate with the cloud and integrate with the upper layers.
Yes, and it's also important that we introduce some concepts which are abstract to the different layers that are below, like what the latency wants, what kind of degree of isolation do we need. These kinds of abstractions can only come with this slicing, and then apply it with several techniques like the ones that you have mentioned, Oscar, at different layers. But we may need in the future 5G advanced networks or 6G to have, for example, deterministic latency, to provide isolation at several layers. So all these kind of new features will require the mixture of these techniques, and that's why I think that's important to foster the research in these topics.
So a third question is about the world where people say that transit networks are dying. That is, where private networks are providing the connectivity between data centers and content distribution sites, and users only use short haul to connect to them. In that world, why is it so important to standardize technology like network slicing and optical inventory management data models? Aren't these just operational techniques that the network operators can develop for themselves and deploy in their own private networks? And maybe this is something for Ricard and Daniel to talk about.
So thank you very much for the question, Adrian. I think that's very interesting to standardize network slicing. We need a common understanding of the different features that it needs to provide, the different requirements to set. Operators typically might deploy several flavors of them, but of course, as they acquire most of the equipment from the vendors, they need some kind of multi-vendor interoperability. That's why standards and open standards are very important.
Maybe Oscar or Håkon would like to have a last word with operators and say why they believe that standardization of these technologies is helpful for networks.
Yeah, thank you, Adrian. So I think this session has really pointed out the need for standardization, and this last topic of how we interconnect our networks is indeed a very challenging topic. It's not purely technology and technology standardization. It's also indeed a matter of business and new service concept innovation. And of course, we have to deal with regulatory issues. I think the 5G setting is changing our context enormously. And we need to innovate also on the interconnection side in order to deal with these new challenges. There are so many opportunities, and we should try to facilitate interconnection models and service concept that indeed allows innovation for a whole new range of players. So there are so many SMEs out there that need specialized connectivity on demand, and we should allow this. So both at the local level, national level, and international level.
I would like to add that standardization is not only something nice. I mean, it is mandatory in this industry to have a common understanding of what we are doing. Imagine if everybody has its own view of the network slicing, what would be a slice? We don't know. I mean, so standardization is key.
So thank you all. I'd like to wrap up the session by thanking our four panelists, Daniel, Ricard, Oscar, and Håkon, And reminding you that if you want to know about TeraFlow and the project, you can find us on the internet, where we have lots of resources.